Okay, good morning, my dear legendary students. This is Krishna, HOD of Zoology, Sri Vasavi Degree College. Welcome back to online webinar of online classes. My dear Paris students, today we are going to discussing about a new topic. Already day after yesterday, we are discussing about transport of gases. We are discussed what is transport of gases, what is difference between oxygen transport and carbon dioxide transport. Okay, so this carbon dioxide today we are discussing about very important topic that is carbon dioxide transport. What ma? That is may audible visible? Okay.
Sir.
Rajita, Radhika, Bushra.
Yes, sir.
Okay. So, Radhika. Okay. So that is today we are discussing about the topic is CO2 transport. What ma? CO transport of CO2, carbon dioxide or CO2 transport. We already discussed previous O2 transport. Okay, what is O2 transport? Transport of oxygen from lungs to tissue. From lungs to tissue, that is through the bloodstream, that is called O2 transport. But whereas here the carbon dioxide transport means what? Can you expect anyone? What is the carbon dioxide transport? What is the definition?
The transport of CO2 from the tissues to the lungs.
Very good, very excellent answer. Excellent answer, Busa. You have done fantastic job. Okay, so that is CO2 transport nothing but transport of CO2. Okay, what happened now? Transport of CO2 from tissue to lungs. Transport of CO2 from tissue to lungs is called what happened ma? That is transport of transport of CO2 from tissue to lungs where through what? Blood. What ma? Through the blood is called CO2 transport. Once and I repeat, what is transport of CO2? CO2 transport nothing but transport of carbon dioxide from tissue to lungs through what is that vehicle is there? Through what? That means through the blood is called CO2. That means CO2 transport. Okay, very important. Where it is produced CO2? Where it is produced CO2? Come and tell me. For example, you know very well. Okay, you know very well. So we are. I think you are listening the class. I'm giving the teach. I'm teaching. My hands are working. Tongue are dancing. Total body is working. Okay, your body is working. Your brain is working. But your total our body to required ATP energy, right? So that ATP energy should be formed by the oxidation process takes place in the cell. So who produced CO2? Nothing but the CO2 is produced in the cells after metabolic activity. So you know very well per minute how much ma? The CO2 produced in the cell. Rich amount of the CO2 again and again the CO2 to be produced in the cells after metabolic activities, right? So by the oxidation reaction, number of a huge amount of the CO2 to be produced in the cell. You know very well our body. So what? For example, okay, per minute, okay, 200 ml. How much? 200 milliliter of CO2 to produce it per minute. How much? Per minute, 200 milliliter of CO2 to produce it from the tissue or cells. Okay, so very important thing. These much amount of the CO2 to be caused to what happened ma? These CO2 which is caused to it is gradually CO2 be raised in the already told you the CO2 should be raised in the cells. What happened ma? So it should be toxic. The cells and tissue should not tolerate that means the toxic nature of carbon dioxide. So nearly per minute, how much CO2 to be produced? Ma? 200 milliliter of CO2 to be produced per minute during the metabolic activity. So this CO2, okay, it toxic to cells. That's why the cells or tissue should not tolerate. Should not tolerate. That means should not tolerate accumulation of carbon dioxide. Okay, it will be caused to human beings. If it is gradually the CO2 level is increasing the world. For example, I would like to, for example, we should take one classroom, the closed classroom, AC chamber. From you are coming to 6 o'clock and I will leave to the class from 6 p.m. without any break. What happened? Ma? Total during that room, okay, the carbon dioxide level is increased. There is no oxygen. But in the tissue, in the cells of your tissue or cells also, there is no oxygen. That's why what happened? Ma? In the tissue, in the cells, the carbon dioxide will gradually increase. So it will be toxic to human beings. The human being should not tolerate. Slightly headache should be formed, vomiting should be formed, fever should be formed, the body temperature should rise, dehydration problems. So many problems to be how to form. For example, the CO2 increases the cell. Okay, ultimately temperature should be raised. Ultimately pH should be raised. Okay, now that's why there is no oxygen. So the tissue cells to be required must be demand. What happened to oxygen? But there is no oxygen in the room. That's why slightly that effects to be come. The effects will come. So what are the effects, ma? Temperature to be rise of the cells, body temperature to be rise. Okay, a headache will be formed. Okay, and that's why. So that is the CO2. It is toxic to cells and tissue. Okay, by the accumulation of carbon dioxide. The tissues and cells should not tolerate the accumulation of CO2. That's why these CO2 must be eliminated from the tissue, eliminated from the cells. Okay, how to eliminate that? These CO2 diffused out into blood. That means RBC is required for the transport of carbon dioxide. Plasma should be required for the transport of carbon dioxide from tissue to lungs. Tissue to lungs. Tissue to lungs. In the lungs, what happened? Immediately, the carbon dioxide removed outside by the expiration process. This is a very important about the that means definition of CO2. What ma? Definition of CO2. Remembering once and I repeat, the transport of carbon dioxide from tissue to lungs through the blood, that is called CO2 transport. Okay, so in the, where it is produced the CO2, the CO2 should be produced. The CO2 should be produced in the remembering one thing, the CO2 should be produced in the cells after metabolic. Per minute, how much CO2 produced? Per minute, how much CO2 produced?
Well, sir. 200 ml.
Very good, Rekha and Radhika, excellent. Okay, so 200 ml per minute. It will be toxic. It will be toxic to human beings. It will be toxic to tissue. It will be toxic to human beings. That's why it must be eliminated. The tissue should be eliminated from tissue to blood. So from tissue to lungs to who carries, that means RBC, that means blood should be carries. Okay, so these RBC, what happened to collect the CO2 and transport to lungs, and the lungs to eliminate the carbon dioxide from lungs to outside. This is called expiration. This is called CO2 transport. But here we will asking the CO2 transport very important. Okay, so how to transport in which mainly the CO2 transport through the vehicles are there. So both the plasma and ions. What happened, ma? The CO2 transport which is responsible for the CO2 transport, which is the transport of CO2 through both number one plasma Number 2, blood. Number 2, blood. Blood nothing but that is RBC. Blood nothing but what ma? That is RBC. Remember it. Blood nothing but that is RBC. You must write RBC. You must write RBC. Clear? So the CO2 transport, some transport of CO2, both what happened ma? Plasma number 1, number 2, RBC. Okay, that is very very important. So nearly remembering one thing. So about 67% of CO2 which is carried by plasma. How much ma? How much percentage? 67%. So how much percentage ma? 67% of CO2 which is carried through the plasma. And remaining 33%, remaining 33% of carbon dioxide which is transport the RBC. This is very very important. Okay, so 67% of carbon dioxide transport by or through what ma? Through how much? What ma? Plasma. 67%. And remaining 33% of carbon dioxide transport by the RBC.
RBC.
Yes, very good. Okay, so this is the very very important. So next one, the carbon dioxide is transport. The carbon dioxide which is carried. The carbon dioxide which is carried by 3 forms are there. How many forms ma? 3 forms are there. So number 1, how many forms ma? The carbon dioxide which is carried by 3 forms. Number 1, number 2, number 3. 3 forms. Number 1, that is number 1 is called carbon dioxide transport as a carbonic acid. As carbonic acid. Carbonic acid, that means H2CO3. H2CO3. Remembering one thing. Okay. Next one, as the carbon dioxide transport as a amino compounds. Amino compounds. Number 1 as a carbonic acid. Okay. Number 2 as a amino compounds. Next one, okay, as a bicarbonates. As bicarbonates. This is very very important. Okay. So once again I repeat, very very important. Board is visible, Radhika. Hello.
Sir, yes sir, it is visible.
Bushra. Visible?
Yes sir, it is visible sir.
Okay, okay, nice. So the letters also visible?
Sir.
Okay, thank you, thank you. Okay, thank you. Bushra, are you there or not?
Sir.
आपको दिख रहा है? Visible?
Yes sir, visible.
Okay, audible?
Yes.
Okay, nice. Thank you, thank you. So the CO2 carried by as a carbonic acid, as a carbon amino compounds, and as a bicarbonates. Right? Very important thing here. So remembering one thing, as a carbonic acid, how much percentage of carbon dioxide transport? How much percentage, man? Remembering one thing, how much percentage? So how much percentage, beta? That is 5% of carbon dioxide which is carried as a carbonic acid. How much percentage, man? 5%. How much percentage, beta? 5% which is carried them as a carbonic acid. Right? Now, next, as a carbo-amino compounds, how much percentage? 10%. How much percentage, ma? 10% of carbon dioxide which is carried. Okay, as a carbo-amino compounds. What, ma? Carbo-amino compounds. Clear? Understood? Now, next coming to the point, as a bicarbonates. As a bicarbonates, how much percentage remaining? Come on, tell me. Remaining percentage out of 100, 5 completed, 10 completed. Remaining what?
85.
85. Very good. Excellent answer. Yeah, I think you are in track. Okay, so that is why today your network is fine. right? So as a carbonic acid 5%, as a carbonyl compound 10%, as a bicarbonates 85%. 85%. This is very important. And one by one we'll discussing about. So as a number one title. Number one title ma as a carbonic acid. As a carbonic acid, remembering one thing. So number one step as a carbonic acid. So H2CO3, how much percentage? Okay. See, 5% of how much percentage ma here in step. What ma? 5% of CO2 dissolve in the plasma. Dissolves in the plasma. Remembering one. For example, the CO2 bind with the H2O. CO2, 5% of CO2 dissolves in the plasma. Dissolve in the plasma. Remembering one thing. To be formed. What ma? H2CO3. Carbonic acid. What ma? Carbonic acid. This is very, very important. Right? And CO2 plus H2O gives rise to H2CO3 mechanism. This mechanism takes place in the tissue. What ma? In the tissue. Okay. So once and I repeat, as a carbonic acid, how much percentage it carries? 5% transport takes place. Okay. So in this plasma, the carbon dioxide, 5% carbon dioxide dissolves in the water. Dissolve the water of the plasma to be form of carbonic acid. The process of where it is takes place reaction tissue. Okay, so this is the reaction is very slow reaction takes place. Next, same reaction. Okay, whereas in lungs, these carbonic acid. Come on, tell me. Already told you. Whereas in lungs, this carbonic acid immediately the carbonic acid should not stable. Carbonic acid should not stable. Immediately converted. Immediately ionized. Immediately ionized. So H2CO3 that means converted into or split into dissociated into water and carbon dioxide. Where it takes place? This is the tissue. Sorry, not tissue. Sorry, lungs. Okay, once and I repeat. So in tissue, carbon dioxide dissolves in the 5% of carbon dioxide combines with the plasma water. This is where my plasma water to the form of H2CO3 in the tissue. So this carbonic acid, which is reach to lungs, immediately through the blood, and immediately dissociation takes place and ionized into H2CO3 to H2O plus CO2. This CO2 will go outside. This is called one of the as a carbonic acid 5%. As a carbonic acid 5%. Now coming to the point. Next, carboamino as a carboamino compounds. Okay, so what ma number 2 as a what ma carboamino compounds. Carboamino compounds. So very, very important. Okay, how much percentage? Come on, tell me. How much percentage through the as a carboamino compounds? How much?
10%.
How much percentage? 10%. How much percentage? 10% is remembering one thing. 10% of carbamino, carbon dioxide, which is carried, which is transported. 10% of carbon dioxide, which is carried or transport through what carbamino compounds. What are the carbamino compounds? RH or NH2. This is called what ma? RNH2. Carbamides. R nothing but carbo. That means carbonic compounds, na? R nothing but carbonic compound. These RNH2 is the carbonic compounds. Carbamino compounds, right? So which is combined with carbon dioxide. Okay, in the plasma. Okay, CO2. What happened, ma? To be formed or what happened, ma? See here, NH. COOH. Okay, so here what are the compounds to be formed? NH or COH. This is called whatever carboxylic group should be formed. Carboxyl should be formed. This is a very important thing. Okay, this where this reaction takes place. Carbon dioxide bind with carbamino compounds to the form of carboxylic compounds. Carbamino carboxylic compounds should be formed. Where it is formed in the tissue. Where it is formed in the tissue. But in reversible reaction takes place in where lungs. But in lungs takes place this reaction. Once and I repeat, as a carbamino compounds, carbon dioxide bind with the origin, carbamino compound to form carboxylic acid. That means carboxy amino acids to be formed. So tissue the reaction, and this reaction, reverse reaction, takes place in the lungs. So immediately RNH to be formed and carbon dioxide to form. This carbon dioxide remove outside by the expiration reaction. By the expiration. This is important about as a carbon. Next, third one. What is the third one? Come on, tell me. What is third one, ma? What is third one? Come on, tell me.
Carbonate.
So, what is that is important? Bicarbonates. As a bicarbonates. Okay, how much percentage? How much percentage, ma?
85, sister.
About 80% of carbon dioxide. Yes, excellent answer, Radhika. About 85% of carbon dioxide, which is transported as a bicarbonates in RBC as well as in plasma. How much percentage, ma? 85% of how much percentage? 85% of carbon dioxide. 85% of carbon dioxide which is transported. Okay, so transported through the RBC as well as in plasma. RBC as well as plasma. So this is important. The major kilo is a bicarbonates, very important. Okay, so this is very important. See, clear? So what is the reaction takes place here? What is the reaction takes place here? For example, so remembering one thing. So here, first of all, these carbon dioxide bind with water, that is RBC and plasma water. So what the carbon dioxide bind with most of the carbon dioxide is combined with water of the plasma, water of the RBC. Right? So to be formed, okay, very important. So what happened, H2CO3 already told in the plasma. Okay, so very important thing here. Then compared to RBC plasma, RBC and plasma, remembering one thing. So more carbonic acid should be formed, should be accelerated vigorously in the RBC than compared to plasma. Why? Come on, tell me. Remember one thing. Once I repeat, the carbonic acid should be accelerated. See here, the carbon dioxide should be bind with water to be formed. A more amount of the carbonic acid should be formed by the enzyme. Accelerated by the reaction is accelerated. Same reaction we already discussed in Verma. So that is as a carbonic acid in the plasma. Right? So what happened here? So in that reaction, so there is no enzyme is present in the plasma reaction. As a carbonic acid directly formed in the plasma, there is no accelerated enzyme. But here in the RBC, remember one thing, it is useful for entrance level. Okay, then compared to RBC, then compared to plasma, the carbonic acid should be formed. More amount of the carbonic acid should be formed very speedily, very acceleratedly should be formed by the enzyme, accelerated by the enzyme. The enzyme is called CA. The enzyme is called what ma? CA. CA nothing but carbonic anhydrase. CA means what ma? CA means carbonic anhydrase enzyme. Which enzyme ma? CA enzyme nothing but carbonic anhydrase. Okay, so this reaction accelerated by an enzyme that is called the carbonic anhydrase. So same, the carbon dioxide bind with water to the form of H2CO3 in the tissue. Okay, immediately what happened? This H2CO3 what happened? Immediately it is ionized. In the presence of you know very well. Here are the that is ionized means what ma? How to ionized? So it is ionized H plus and HCO3 minus. H plus and HCO3 minus H plus. Clear? Once I repeat, CO2 combined with water in the plasma as well as RBC. RBC it is accelerated then compared to plasma because of what? This reaction accelerated in the
Carbonic anhydrase enzyme.
very important. Remember one thing. Because of it is a CA is present. Carbonic anhydrase enzyme is present. Remember one thing, right? So that's why the reaction is accelerated by the enzyme. That is carbonic anhydrase is there. CO plus CO2 plus H2O decides to carbonic acid form in the tissue. In this tissue, what happened? Immediately carbonic acid not stable. Immediately it should be ionized H plus and HCO3 minus. H plus and HCO3 minus. So very important thing. And the same reaction, remembering one thing, same reaction, remembering one thing, it will be reversed. What happened? It will be takes place in the where? It is takes place in the tissue, in the lungs. In the lungs, the reaction must be reversed. Must be takes place reversed. How to form of? Come on, tell me. In the tissue, CO2 combined with water. In the tissue, in the presence of Ca, more carbonic acid form. This more carbonic acid ionized H plus and CO3. More hydrogen ions, more positive charge. That means in the RBC. Remembering one thing. In the RBC. So. You know very well, rich amount of the hydrogen ions to be formed, rich amount of the carbonic acid. The carbonic acid, this bicarbonic ions to be formed in the tissue. In the presence of what enzyme? Carbonic anhydrase enzyme. Whereas in lungs, it will be the reaction should be reversed. HCO3 combined with water, combined with hydrogen ions in form of H2CO3. H2CO3 immediately what happened? So dissociation into CO2 plus H2O. This CO2 what happened? Removed outside by the expiration. That is one of the important things. Number one, once I repeat, what happened? This is the number one step. Number two step, what? In the tissue. In the tissue, I am asking about. So these hydrogen ions in the tissue, these hydrogen ions already we discussed in the oxygen transport. Come on, tell me, in the tissue, these hydrogen ions which is combined. What happened, ma? When the hydrogen ions combines with, okay, so what are these hydrogen ions? Okay, combined with HbO2. Second reaction, what, ma? These hydrogen ions combined with okay, oxyhemoglobin. That means what happened, ma? Whether the hydrogen ions, these hydrogen ions, what happened, ma? These hydrogen ions combined with the oxyhemoglobin immediately, what happened, ma? So the oxygen dissociation takes place. So here, what happened, ma? Hydrogen hemoglobin or reduced hemoglobin should be formed. Hydrogen hemoglobin or reduced hemoglobin should be formed, and what, ma? Oxygen is unloaded. The oxygen should be released. These oxygen diffuse into tissue. Whereas we are discussing Bohr effect, na? Whereas discussed in bore, I've already told you. So these oxygen enters into whatever released into blood, this oxygen diffuse into tissue. Okay, so that is important thing. Okay, so and this process takes place in where? This process takes place in where, man? Tissue. Once I repeat, remember one thing, whether the so this carbon dioxide, it is more carbon dioxide, already told you na, more carbon dioxide which is what I mean, transported with help of carried by plasma. Actually, the carbon dioxide present in the plasma, not RBC. Remembering one thing. So this carbon dioxide diffused into RBC. Diffused into RBC. In the RBC, the reaction should be accelerated because why? Why? For example, remembering one thing, this is the RBC cells, man. This is RBC cell. But actually CO2, rich amount of the CO2 is present in the plasma. CO2 which is present in the plasma, remembering one thing. But why the carbon dioxide which is diffused into RBC? Anybody can say? Actually, remembering one thing, the CO2 present in the plasma, huge amount of the CO2 which is present in the plasma, but transport of this carbon dioxide through plasma as well as RBC. But plasma 80, plasma how much percentage already told you? 67% of plasma involved for the carried of CO2. So totally 67% of carbon dioxide which is present in the plasma. But that plasma, already carbonic acid already told you, okay, only 5%. Why? But these carbon dioxide diffused into RBC. Why? So, come on, tell me. Anybody can say? Anybody can say? Hello?
Dioxide bind with water and form H2CO3 ions.
Okay, my question, remembering one thing, my question you must be try to understand. Already first point already told. Okay, the first step. So through the as a carbonic acid, only 5% transport in the plasma, of course. So here also in the plasma also carbon dioxide bound with water to the form of carbonic acid. Only 5%. But whereas in bicarbonic acid, but this CO2 which is why diffused into RBC. Why diffused into RBC? Come on, tell me. Because of in RBC which enzyme is present? Which enzyme is present? Enzyme already told you na?
Anhydrase.
Carbonic anhydrase enzyme is present. Okay, Rekha, nice. Rekha and Bushra is nice, excellent answer. So that's why in the RBC, carbonic anhydrase enzyme is there. That's why, sir. So huge amount of the carbon dioxide diffused from plasma to diffused into from plasma to RBC. So in that RBC, what happened, ma? The carbon dioxide bind with water to form of H2CO3 in the tissue. These H2CO3 ionized immediately, H plus and HCO3 minus. These HCO3 reach to what happened, my lungs. But H plus ions, what happened, immediately, positively charged, immediately bind with what happened, oxyhemoglobin in form of reduced hemoglobin or hydrogen hemoglobin, whatever it may be. Hydrogen hemoglobin, and what the oxygen should be released. These oxygen should be enters into what happened, ma? These oxygen should be enters into tissue. Okay, and so this is clear. Okay, now so and whereas, come on, tell me. Whereas same reaction is reversed. Same reaction is reversed. What happened? Okay, same reaction. What happened first? So same reaction reversed. How to form of? Come on, tell me. So O2 in lungs and reverse. The O2 is enters into lungs of blood capillaries. The O2 enters into lungs. That O2 enters into bloodstream. So that O2 bind with reduced hemoglobin, and to the form of HbO2 and H plus. H plus. And what happened, ma? These H plus immediately bind with carbonic acid, carbonic ions to the form of what happened, ma? So by carbonic acid. This carbonic acid immediately what happened, ma? Dissociation takes place. CO2 and H2O, and this CO2 removed outside. What? So this process is what, ma? in tissue straight reaction, but whereas in lungs reverse reaction. You must be right 2. Okay, that's why I given only one mechanism. In the tissue, what happened, ma? For example, from plasma CO2 enters into RBC cell. In the RBC CO2 combined with water, water in the form of carbonic acid. In the presence, it should be accelerated. The enzyme is called carbonic anhydrase. This carbonic acid immediately ionized and in the form of hydrogen ions and HCO3 ions. These hydrogen ions, remembering one thing. These hydrogen ions, okay, immediately bind with what happened now? Oxyhemoglobin. The oxygen should be released into tissue. Okay, and reduced hemoglobin, oxygen to be released into tissue. Okay, now. So whereas in lungs, the reverse reaction takes place. Come on, tell me. Third, in the lungs, what happened now? The oxygen which is unload of oxygen into loosely bind with reduced hemoglobin to the form of oxyhemoglobin. Hydrogen ions should be formed. These hydrogen ions immediately already in the lungs, what we are carried the carbonic acid. What happened? So these carbonic acid bind with bicarbonate ions bind with hydrogen to the form of carbonic acid. This carbonic acid to the form of immediate dissociation takes place. Carbon dioxide, water. This carbon dioxide removed oxygen by the expansion. This is a transport of bicarbonate. So here one problem is faced, ma'am. One problem is facing here. Come on, tell me. What problem here facing? So this is the mechanism, of course. Okay, here carbon in the RBC. Remember one thing, in the RBC. Okay, so carbonic acid is present then compared to plasma. So in this carbonic acid, huge amount of the huge amount of the carbonic, that means bicarbonate ions should be formed. Huge amount of the hydrogen ions also, that means here positively charged particles also raised and bicarbonate ions also be raised. For how to balancing, how to neutralize it. That's why we are required to discussing about, that is chloride shift. Chloride shift. Now we are discussing about chloride shift. Okay, what is important? See, chloride shift. What is chloride shift? Okay, what is chloride shift? Come on, tell me. Diffusion of chloride ions into RBC from the plasma, and what happened, ma? Back is called. What happened, ma? So come on, tell me. Remembering one thing, I would like to draw the diagram. What is chloride shift? What is chloride shift? Come on, tell me. The diffusion of chloride ions into the RBC from where? Plasma, and back is called flush. For example, this is what happened, ma? RBC. This is what, ma? This is RBC cell. Okay, what happened, ma? The diffusion of chloride ions. Diffusion of chloride ions from, this is plasma. This is called what, ma? Plasma. This is called plasma. So the chloride ions diffused into, what is this? Come on, tell me. What is this, ma? This is RBC cell. These chloride ions diffused into RBC cell and get back. This is a reaction. Remembering one thing. Okay, so that is the reaction is called what happened, ma? So chloride shift. Once I repeat, diffusion of chloride ions from plasma to RBC and get back is called chloride shift. This chloride shift was discovered by who scientist? Hamburger. What, ma? Hamburger scientist. Who scientist, ma? Hamburger. Hamburger scientist. Okay. So Hamburger scientist. That's why this phenomena is called Hamburger phenomenon. Hamburger phenomenon. Once I repeat that, chloride shift, the diffusion of chloride ions from plasma to diffusion into the chloride diffusion of chloride ions. That means the diffusion of chloride ions from into RBC from plasma to and get back is called chloride shift. So this chloride shift was discovered by who's ma? Hamburger scientist. Which ma? Hamburger scientist. Okay, so this is very very important. That's why it's called Hamburger phenomenon. Hamburger phenomenon. How? How to take place? Come on, tell me. For example, the CO2. This is plasma. This is plasma. Okay. So in the plasma, this is what is present. This CO2 diffused into RBC. Just now I told you na. This CO2 diffused into RBC. What I mean, this CO2 bind with water. Come on, tell me. Bind with water to be formed. Bind with water to be formed. What ma? H2CO3. H2CO3. Immediately these H2CO3 releases what happened ma? These H2CO3. So these H2CO3 immediately ionized. Immediately ionized HCO3 by carbonate ions and negative charged particles, and H plus ions also what ma? So positive charged particles. Positive charged particles. This is very very important. Okay, very very important thing. So here, what is the problems you are facing? So here, which enzyme is present? Ca is present, na? Carbonic anhydrous is present. More amount of the what happened, na? Carbonic acid from these carbonics are immediately ionized into H plus and HCO. H plus and HCO. These HCO3, what happened, ma? Immediately more concentration of carbonate ions should be formed, negative charge. So these negative charged particles of bicarbonate ions, which is moved from, always remembering one, the diffusion process. The molecules which are moved from high concentration to lower concentration. In the plasma, there is no bicarbonate ions. That means low concentration of bicarbonate. That's why these high concentration of bicarbonate ions, which is negative charged ions, which is moved from RBC to plasma. RBC to plasma. Vice versa, for the balancing of these, bicarbonate ions. So whether, remembering one thing, these carbonic ions, so that means carbonic ions, bicarbonate ions, which is moved from RBC to plasma. Here balancing purpose, here more hydrogen, that means negative charge, that means positive charged hydrogen also to be raised. For the balancing of these ions, how much bicarbonate ions move from RBC to that means plasma. In the same vice versa, the chloride ions which are diffused from plasma to what ma? Plasma to very very important. Plasma to so the shift to the chloride ions from plasma to RBC, balance it, neutralize it. Okay, neutralize it for. But here one more problem also facing. And what happened ma? See, remembering one thing, these mechanism, these hydrogen ions, what happened ma? Bind with what ma? So bind with the hemoglobin. What should be formed? Reduced hemoglobin should be formed. Right? So whether reduced hemoglobin should be formed, okay, very important thing. And immediately, so these carbonic acids, this what ma? These blood should be. This the reaction takes place in the tissue. And these reactions see vice versa. What happened, ma? It reached to lungs. And reversed. Okay, and the chloride ions which are moved from reverse direction. The chloride ions which is moved from RBC to plasma. Ultimately, the bicarbonate, that means bicarbonic ions which are moved from plasma to RBC, and to be formed what happened in the blood capillaries. So these carbonic acid bind with what happened ma? So immediately hydrogen where in lungs I am saying that in lungs to be form of carbonic acid. The carbonic acid which is split into carbon dioxide and water. the carbon dioxide removed outside. Just now I told you na. So this is called what happened ma? Remembering one thing, chloride shift. For the chloride shift. So very very important. What is chloride shift? Diffusion of chloride ions into the RBC from plasma and get back is called chloride shift. From the tissue, whatever cells, the tissue cell to whatever CO2 diffuse into the RBC. From the whatever the plasma of tissue, the CO2 diffuse into RBC, the CO2 combined with water to be form of whatever carbonic acid. These carbonic acid, okay, immediately ionized H plus and SCO3. These SCO3 ions move from RBC to plasma. Vice versa, the chloride ions are shift from plasma to. This is called a chloride shift. Okay, now so here the bicarbonate ions are negatively charged in they diffuse from plasma, diffuse into plasma from the RBC. And ultimately, the hydrogen ions are to be combined. The hydrogen ions, that means positive ions, are which are present in the RBC. In the RBC, hemoglobin is there. This hemoglobin combined with the H plus to be form of reduced hemoglobin, which is moves to what happened in the lungs. The reverse reaction is there. Here in the lungs, reverse chloride shift takes place. Reversed chloride shift takes place. That is called so very very important. That is called Alden effect. That is called what ma? Alden effect. So the chloride shift takes place in the lungs. It is the reverse. Lungs is reverse. That means the chloride ions shift from what happened RBC to plasma. RBC to plasma, and bicarbonic ions, which is what must shift from what happened moves from plasma to. And these carbonic acid, the bicarbonate ions combined with the H plus to be form of H2CO3 and to be split into CO2 and what happened H2O. CO2 removed through the lungs by the expression. I hope understand. So this is a chloride shift. Okay. So and carbon dioxide transport. Once and I repeat, the carbon dioxide transport, the transport of carbon dioxide from tissue. That means tissue to what happened lungs. Tissue to lungs. That is called carbon dioxide transport. Per minute, 200 milliliters of carbon dioxide to be produced. These carbon dioxide should not tolerate our cells. Okay, so this carbon dioxide which is carried two forms. The one is as well as both plasma and RBC. Plasma 67%, RBC 33%. And these carbon dioxide carry three forms. One is as a carbonic acid 5%, as a carbon compounds 10%, the bicarbonic acids which is 85%. Remembering one thing, why the more carbonic acid formed in the RBC? Because of in the RBC carbonic anhydrous is present. That's why more carbonic acid and formed in the RBC than compared to plasma. Okay, so this is a chloride shift. So whether the carbon dioxide diffusion from tissue to, that means plasma to RBC to the form of H2CO3, immediately dissociation ionized H plus and HCO3. This HCO3, more HCO3 negatively charged, which is moves from RBC to plasma. Ultimately, for the balancing purpose, so from plasma, chloride ions which is shifted from plasma to RBC. That's why it is called chloride shift. Here, one H plus ions also to be more positively charged. These present in the inside of the RBC. Remembering one thing. These H plus ions to bind with the hemoglobin to the form of reduced hemoglobin. And the same chloride shift reaction, reverse reaction takes place where lungs. That is called a reverse chloride shift. The reverse chloride shift is called Alden effect. Okay, so this is, I think, hope understand what is transport of gases. Describe the transport of gases. Oxygen transport. Sometimes what is the transport of gases? Describe the carbon dioxide transport. Okay, now sometimes describe the transport of gases. And that means you must write O2 and you must write carbon dioxide. Okay, now I think very very important. So major topic of respiration is completed. And the respiration process, controlling of respiration process, tomorrow we will discuss. and get ready for a seminar and in this Friday and Saturday. Okay. Yes. Okay. I think once I repeat, you must be seen. Those who are missed, those who are missed. This session will be going to upload in YouTube, and don't forget about it. And you must be see once again in the YouTube because of we want watching time 4,000 minutes and near our channel nearer to 1,000 subscribers for AdSync. So please subscribe our channel, like it, comment it, and share it. So for regarding your friends, thank you very much. This is Krishna, HOD of Zoology, signing out.